Okay, last part here in solving systems of equations and kind of the mechanics of how it works is sometimes when the inspection failed to be done or you didn't really notice that this equations were actually the same with two different answers like 2x plus 3y equals 6 and 2x plus 3y equals 10. By inspection, you should be able to say there's no solution because cannot also be equal to 6 and be equal to 10. But let's just say that you didn't see that, and we went ahead and we decided, okay, we're going to solve the system by elimination. So I'm going to, let's see, I want to make these cancel, so I'm going to multiply this whole equation by -1 to make that a -2, just so I can eliminate the x's. So when I do that, I get -2x, -3y, -10 when I multiply both sides of the equation by -1. And now I'm going to add these two equations together just by my typical method of elimination. So when I add them together, I get 0 x's. And then I am surprised by this, right? 3y minus 3y. I also get 0 y's is equal to -4. Well, 0 times x is just 0, and 0 times y is just 0. So I get 0 plus 0, which is just 0. So I get 0 equals -4. And I say, well, that can't be. Like 0 is not equal to -4, right? So this is a case where there is no solution. Okay. So we should have saw that in the beginning with inspection, but if we didn't see it and we went through the process and then we end up with something like this that is not true, then we say, well, it doesn't matter what the x's are and y's are. This could never be true, right? And then maybe we run into a situation like this where 2x plus 3y equals 6, and then we had 4x plus 6y is equal to 12, right? And I wanted to manipulate this equation. So maybe I multiply this equation by -2. So then I get -4x, -6y equals -12. And then when I add the equations together, I get 0 x's plus 0 y's. So this is all 0 is equal to 12 minus 12, which is also 0. So actually 0 is equal to 0. So this is true, right? So in this one I ended up with something that was false. So there's no solution that would make it true. This one already is true, and actually it doesn't really matter as long as I find something that makes that true. 2x plus 3y is equal to 6. As long as I find something that makes that true, it would also make that true. Right, because these are really just the same equation. If I divided this by 2, I would get that same equation. So this has an infinite number of solutions. Okay, and the same thing happens when we solve something by substitution. If you don't see immediately that there should be no solution or infinite number of solutions just by inspection, if you go through the process of doing the problem, like let's say, I don't know, y equals x plus 2, and maybe x minus y equals -2. I think that's the same equation. Yeah, so if I substitute this in for y, so I get x minus y, so it's minus that whole thing. So I have to put it in parentheses, equals -2. And then I distribute the negative sign, or it's the opposite of both of those. So x minus 2 is equal to -2. X minus x is 0, so it just goes away. So I get -2 is equal to -2. So this is true, so there's infinite solutions. And if you rearrange this equation, you would see that, so subtract x on both sides and then divide by -1. This would also be y equals x plus 2. So they're identical equations. If I were to solve by substitution something that was like x minus y is equal to 5, so I substitute in and I get x minus x plus 2 equals 5, and then I do what I did before, and then I get -2 equals 5. See, this is false. So there is no solution. There's no values of x and y that would make both of these statements true at the same time. Okay, so no intersection point. And if I were to graph these, I would have parallel lines. If I were to graph these, it would be the same line right on top of each other. Going back here, no solution means these two lines, when I graph them, would be parallel. So something like that. If I were to graph these, they would be the same line, right? So the same line right on top of itself. Okay?